Till now, we have seen that we have taken the categorical features. They are a binary kind of till now that we have seen that the categorical features that we have taken in this series of lectures, that two kinds or almost 10, yeah, 5 kinds of features. And first, the categorical features that we have seen is either 2 or 3 or 5 or at most 10. Okay, or at most 10. These kind of features we have already considered. But the problem is that if we have a category features, that we have many possible value. Suppose let's take, I think it will be better if you take an example. Suppose let's take a zip code of a country, or a simple pin code of a country. If we take the consider pin code or zip code of a country, if we consider, then there may chance high value of this category. If our category is, suppose if our features is pin code or zip code. So suppose let's take for a country, they are have the pin code. Suppose let's take 10,000 10k pin codes we have. So in such scenario, if we consider these features, then how much category we have? So for these features we have 10k category. So if suppose let's take we have a data sets d, if we have a data sets d, and corresponding to these features, if we splitting this data set, suppose let's take for this feature, suppose let's take these features, we call these features pin code. Okay, so if we splitting these features corresponding to this splitting the data set corresponding to this feature, so there may be a chance, there chance to split this data. So 10k possibilities to splitting this data. If we using the pin code features corresponding to each category, there have chances to splitting this data in near about 10k categories. 10k splitting. Let's take d10k. So after sometimes we have seen that we are splitting the whole data set in small chunks of data. Suppose let's take, after small splitting we have got for this splitting value, we got, suppose here only 10 value occurs. Okay, but where here actually our number of data sets, suppose let's take here number of data for the d, suppose let's take 500k. We have 500k data points in our parent data set, but after splitting in the child data sets, we have got only 10 points. So this thing is totally negligible. Totally we can easily neglect these features. Okay, these may be outliers, or this may be a misclassify point, something else it may be. But how to resolve this issue if we have such kind of many possible values for a category, for a categorical features? How to remove this thing? So there have a nice hack so to remove this thing. So let's see. Actually, because the main problem is, suppose the problem is very small, number is very small. I think it is always better before solving a before solving something, if you just write down your problem, it is always better. The problem is, so our number of data sets of d4 is equals to very small. Okay, this is the main problem. So it may be outlier. It may be outlier. and also and maybe outlier or maybe misclassified point. Misclassified. It is misclassified point. So the main problem is arise here. So how to resolve this thing? Let's see. So the main hack to resolve this thing is features engine. Features engineering. Here we have apply simple features engineering. That thing also we have seen in SBM when we have learned and the SBM chapters. Then this thing also we have seen features engineering. Now let's see how this features engineering technique, mathematical technique we have used. We will used here. Let's see. Suppose let's take and let's first draw the data frame. Suppose let's take this is our data frame. Okay, this is our data frame. This is our, suppose let's take this is our pin code. This is our pin code, and this is our corresponding in output level, output class level corresponding. Suppose let's take, suppose for our simplicity, let's take our class level is 1, either 1 or 0. Binary classifier I am taking, and it is a categorical features. It's a categorical features. Okay, pin code. So suppose we have 10 can, suppose the number of pin code of a country, suppose let's take they are have 10k number of possibilities, 1 2 3 4 dot 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 dot. For a country we have, suppose let's take 10k number of pin codes for this country. Means once means this, actually don't be confused, it will be better pin 1 pin 2 pin 3, it will always better. Suppose let's take it's pin 1, it's pin 2, it's pin 3. Suppose let's take it's pin 10k. Okay, so how much? Suppose let's take corresponding to, suppose for this, suppose let's take it's the data point, it is the data point, x1 data point, x2 data point, x3 data point, x4 data point. So suppose let's take we have 500k data point, 500k data point. And suppose for this corresponding data point, suppose x1 data points our pin code is, suppose let's take its pin code is pin 1. Suppose for x2 data set, let's take its pin code is pin 30. Suppose let's take for x3 data set, its pin code is pin 900. Like that. Okay, like that. So for 5000 pin, suppose let's take its pin equals to 1500. Okay, like that. And corresponding class level is like that. That for class level is, suppose let's take its class level is 0, it's 1, it's 1 is 0. No, suppose let's take it's 1 class. Suppose like kind of like that we have the data set. Okay, now the thing is how we will doing the splitting, how we will, the main thing that we have to convert these categorical features. First job we have to do the first job that we have to do, first convert these categorical features into a numerical features. This is the main technique here. Now let's see how we will convert these categorical features to a numerical features. First we have to convert the categorical features to a numerical features. Okay, now this is the main thing, how we will convert this thing. Okay, this is the main interesting and very interesting thing. So let's see. So here actually pin code pin 1 pin 2 pin 3 everything is actually a category. category, categorical quantity. Sure, it is a categorical quantity. First we have to find the probability. So probability means probability for h pin. So probably we have to find the probability of, I think it is better if we just take a different color. Probability of pin, suppose let's take I am interested in probability of pin j. Means how we are calculating, we have splitting our data set, we have divided our whole the things we have actually we have actually binary classifier. We can easily splitting our data sets by one for one splitting and another. Suppose we have, suppose it will be better, let's draw the picture. This one, this one, we will split our whole data set. Suppose here actually it is yi. So in the first chunk of data, we will divided the whole data set D in such a way that suppose it is D1 and it is the chunk of D2. In D1, we have taken only 1 points, only one, the category, only one, only first category. And in the second chunk, we have taken only the third or the class level, only 0. That class level only 0. That in second level we are considering this one, and that kind of. And in first one we have considering only one. Okay, I think you have understand. Now corresponding to the h, for each class level we can store this value. So first one, what? First one is pin 1. Here we have store pin 1. Next, what pin 1 for 0? Pin 0. Suppose let's take this value for pin 0 is equals to pin, suppose let's take its value is 9 in a 9 9. Suppose let's take fourth one. So here now value will be pin 9 and 9 9. So how much value we had? Suppose let's take dot. That's will easily store. Now what will be the value here? So here first value will be what? Pin 30. Here first value will be pin 30. Second value will be what? Pin 900. Like that. So last one will be pin 500. 1500 in 1500. Okay, such kind of like we have partitions. Now we have to find the conditional probability. Means what? Conditional probability of our yi is equals to 1 for a given particular pin j, for this pin j. Okay, we have to find this probability. Suppose let's take this probability we call pin j. Suppose okay, no problem, don't be confused. So suppose we have to calculate this probability. This probability means what? If you just using the definitions of this probability, so these definitions will be our the number of probability. In numerator we have, first see the denominator part. In the denominator part, number of total pin j that have occurred, number of pin j that have occurred in total whole our data sets. Okay, this means what? This means, these things means what? This thing means from our whole data sets, first we have to count from our whole data sets D. From our whole data set, first we have to count number of total pin j. Total pin j. We can easily count pin j. Suppose let's take an example pin 30. Then suppose let's take for this one, for this x2 we have pin 30. Then for x19 we have pin 30. For 50 we have pin 30. Such kind of count we have to do. So first we have to count the total number of pin j that occurred in our set D. So total pin j in D. Okay, and in numerator it will be the pin j in d1 means how much pin j we have. Pin j in d1 or other language you can written our pin j and our class level is equals to 1. Array number of pin j in our class level is equals to 1, or number of total pin j in the whole data set D. This is the simple formula. Suppose let's take the similarly for we can easily count for y is equals to 0 for using the data set D2. Here we are using 1. If we are using 0, then similarly here we can easily construct D2. If we take in the D2, then you can easily find this probability for D2 class also. We can easily find this probability. So now the thing is how to, suppose let's take an example. Suppose let's take here I am taking an example for better understanding. Suppose let's take we have a interest to we have for this data set we have find that 20 times we find that 20 times we find pin j for this whole data set D. We will find 20 times pin j. Okay, and in this 20 time we find here 19 time pin j. In the whole data set we find 20 times, and in this only in this data set we find 19 times pin j. Okay, so how much value would be? Here we have 19 times, and so only one times it will be here. So now it will be 1 times pin j, 1 time pin j occur in D2. So now what will be the value now for this one? Just neglect this one. Just I am using the same color, yellow color. Just see the yellow color. So now pin j for the class 1, its value will be 19 by 20. 19 by 20, and the for the probability for the this one for this class 0 class, its probability will be 1 by 20. So for numerical features you can assume any one of the value. Okay, for numerical we have to just actually we have to convert categorical to numerical features. So suppose let's take our now features each. Now we have converting our features like that. Now or we are converting these numerical these categorical features, that is pin 1, pin 2, pin 3 to suppose let's take p1. So now we are converting categorical to numerical. How we will convert? In category we have in 1. Now we can find its corresponding p1. P1 means what? P1 means probability of yi is equals to 1 given in 1, or you can, if you interested, you can take 1 or you can take 0 as your wish. No problem, that's no problem. So as your wish, just you can consider any one class. Similarly for we can convert this pin2 as a numerical quantity p2. The same formula was applicable here. For each category now we can easily convert each category. We have 10k 10k pin, we have to assume we have 10k pin. we can easily convert this thing. Okay, I think you will understand. Now if we can easily convert this categorical to numerical, now what we will do? Now from our data sets we will remove this pin category. We will remove this pin category. Now in the second step, what we will do? Now in this step we have to do, we remove pin features, pin features from D and insert these features, insert PIs, insert PIs features. Now we have to insert these PI features. We have to remove pin features from our whole D and we have to insert these PI features into the main data set D. Okay, you can insert PI, or you can, if you calculated UI is equals to 0 for this. Okay, I think you have understand this thing. So this is a numerical features. Now this is a simple numerical features, and this one is the categorical features. This is the categorical features. Okay, very simple. We have to doing this hack, nothing else. So now the just previous lecture that we have already seen that how to splitting whole the data set by using simple numerical. The same things also we have applied here. So now our we have removed these categorical features from our data sets and we insert in our data set PIs numerical. Now by doing this job we can easily convert it. So our now data sets D we have splitting, suppose let's take, now we have splitting our PJs less than is equals to 0.2 something. So if yes, then we can splitting our data sets like that. If no, we can splitting our data set like that. We can easily doing the same job for these edge features, for these edge numerical features, for edge numerical features. So this will be, let's take D1, this will be, let's take D2. Easily, instead of here we can easily stop doing this job, but here what will be? If we just consider the categorical features here, then what will, suppose let's take, we are using pin, we are using this code, pin code, then according to that we have finding that how many category we have. We have suppose D1, D2, D3, like D 100k, 10k, 10 kind of splitting we have doing here. Okay, because of this, for according to this here, pin 1 we have doing this job, for pin 2 we have doing this job, for pin 3 we have doing this job, for pin 10k. Okay, we have doing this job, but here we can easily solve this issue. We can easily solve this issue by using simple this hack. So now this pin now is converted to this PJ by simple using the probability of our yi is equals to 1 for a given pin j. Okay, this is the simple elegant hack that we have to make to handle these many categorical possible values for a categorical data, for a categorical features. If we have a categorical features that have many categories, so we have to doing this simple elegant hack to convert this category to a numerical. Then easily you can easily resolve this issue. I think the geometrical, from these examples, from these explanations, from these examples, I think the concept, this features engineering concept is clear. How to doing, how to handle these many possible categorical values to splitting the data set. So by simple this omit this thing, by simple omit this thing, how to do it. I think this lecture is clear. Okay, although if you have any problem, please I request you, please revisit again. Then I think then although then after that, if you after revisiting this lecture, if you have any problem, please comment below. Or also in my YouTube channel, I also give my email link. If you have any problem, then please personally email me. I will try to give the explanation as simple as possible. Okay.